All right, we're going to talk about an interesting property and behavior of the solution. Okay, start right here. So if I have a container filled with water, all right, so this is a bigger with the water sitting on a bench. 2 days later, what's going to happen to it? Well, it just disappear, right? Water just disappear because water vaporize slowly from liquid go to gas slowly. So this is what we call vaporization. All right. Now, if I do that in the a two compartment and it's a closed system, okay? So there's two compartment, compartment A, compartment B. So what will happen after several days at room temperature? Well, first of all, the water in compartment A and B will vaporize, right? Fill up. So water will, the gas will assume the shape of the container, so it would expand, occupy the whole container. So water will go up, 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 up. So we lost some water, but water will go up to become vapor. All right, and the exchange rate of water molecules between A and B is going to be equal. All right, when the water molecules at the top, this compartment right here, saturates, so some of them will condense back to become water. So we get water a bit back here. So everything will become in equilibrium. So it just stay right there, nothing different. All right. Now, if I add salt into compartment B, so add a sodium chloride salt, so the sodium chloride, okay, what's going to happen several days later? Actually, we're going to find out that this happened. All water in compartment A goes to compartment B. Yeah, that's what happened. Right? So what's going on here? This is the explanation. In compartment A, no salt. The rate of vaporization and condensation, so water goes up to become vapor and vapor condensed down to water, still the same, nothing different. But in compartment B, that's different now. The rate of vaporization is slower, much slower, depends on how much you add sodium chloride in it. Right? The rate of condensation the same, coming down to become water still the same, but the rate going up to become vapor is lower, only because the interaction of the ion dipole interaction between water molecules and chloride ion and a sodium ion. Water molecules from liquid water molecule want to go up, vaporize to become vapor. Sodium chloride say, no, don't leave me, pull this water back and stay with them. Okay, that's why the rate of vaporization in compartment B is lower. And when the rate of vaporization in compartment B is lower, the amount of vapor is going to be lower as well. So the vapor water in compartment A have to compensate the low vapor in compartment B by migrate some of those to compartment B to keep the equilibrium. Okay, and over time, since the vapor in compartment A is losing to compartment B, the rate of vaporization in compartment A goes higher and higher and higher. So just keep adding, try to stay at equilibrium, but never be equilibrium in here. Eventually, the amount of water in compartment A is going to be lower, and it's gone. All right. So it's all about this salt, right? So colligative properties, yeah, which is a property of solution that depends upon concentration of solute, molecule, or ions, but not upon the identity of the solute. So you can add sodium chloride, you can use magnesium chloride, you can use potassium iodide, whatever in here, anything that dissolve in water, and it do the same way. Okay, the only change is the amount that you add. Right, so there will be effect in colligative the extent of colligative property. Sodium chloride, magnesium chloride, sugar molecule, they do the same thing as long as they can interact with water. Okay, and the colligative property, there are few type of colligative property. We have the freezing point depression, boiling point elevation, vapor pressure lowering, so you saw earlier, and then osmotic pressure. I love the last one. Well, it's fun to talk about. Okay, so we're going to start with the freezing point depression. Adding sodium chloride, the freezing point goes down. All right, how that works? Let's take a look on the